All right. So welcome, guys. Thank you for attending this quickie talk about functional Groovy. I will only take 15 minutes out of your time while you enjoy your meal. Well, the more in details about me is basically I love the Groovy. I breathe the Groovy. I work with Groovy every single day of my work life. So I think that I know a few things about Groovy. Usually, when you think about functional programming in the JVM, we think immediately about these two languages. Either it's a Scala or it's Clojure. Whether you like a little bit more of a hybrid approach with a Scala, or you like to have the purity of functional programming with Clojure, that's okay. So why do I bring the topic of Groovy in terms of functional programming? So let's see a few hands. Who is already comfortable with Groovy? Who knows a little bit of Groovy in the audience? So a bit of hands. Okay, so this talk is perfect for you guys because the idea is to showcase what you can do with Groovy in terms of functional programming. Now, the next thing you think about is, well, Groovy is dynamic and it's object-oriented, so how can you actually do functional programming with this thing? Because, well, it's not thought, it was not designed to be a functional programming language. And of course, then you have to come to terms with this. If you're looking for a language that has all the purity of functional programming, then Groovy is not it. The only language right now that you can look at it is probably Haskell. Now this fellow right here, Russell, he's one of the committee organizers of DevOps, so he knows exactly the topic about functional programming and Groovy. I should also tell you that if you really want to run something that looks like Haskell on top of the JVM, then have a look at Frege. It's very much close to Haskell. So, basically, in Groovy we have closures. You can think roughly closures are equal to functions, as in the other languages. There is one thing that closures, well, there are just codes, blocks of code. They may take arguments. So this syntax looks a lot like the JDK8 syntax for lambdas. Some people may say, well, JDK8 was a little bit inspired by Groovy and Scala by their syntax. Well, it's still up to debate. But you can call closures in two ways. Either you assign it to a variable and just call it as it is right here, or use this method whose name is called. This special method name will come back later in another slide. You'll see why it's used in this way. Another interesting thing to remember is that closures in Groovy are not side effect free. Because what this example is showing is that the closure has a reference to the enclosing environment. There is a variable defined outside. Within the closure, I can change that variable and then get this impressive result. Remember that. Parameters, you can, because Groovy is dynamic, you may define the types if you need them. Otherwise, just leave them out. My personal preference is if I need the type, if I know what the type of a certain variable is, then I put it. What's the advantage in a dynamic language? Because you're working in a team environment, it's much easier for the other team members to recognize what the code is doing. Of course, you will add proper tests and documentation, but if you can see the types, then just put it there. Groovy supports optional typing. You may have access to default parameters. This is a feature copied from other languages. This is nice. The default parameters have to be defined from the right to the left. You cannot define default parameters in the middle. And some examples of that. If you do not define a name for a variable, a closure will always have access to a default parameter whose name is it. So notice these two definitions. Behavior-wise, these two closures are equivalent. But in the case of this definition, I am defining exactly that it takes one parameter. I don't know the type, but I know the name. But for this other one, it takes the default name. So you can call them exactly in the same way. If you need to define a closure that takes no arguments, you must use this format. Just an empty arrow, no parameters definition. Now that we know what closures and functions are in Groovy, then we can go to the following list of topics. This is one of the things what I keep talking about functional Groovy now that we have JDK 8, because lambdas in JDK 8 do not provide some of these features. These are some of them are unique to Groovy, and some others, well, I don't know if we're ever going to see them at later stages of the JDK 8. Here are some examples of iterators methods. Many of these can be used with JDK 8. There is I don't think I'm showing an each method or for each method that JDK added to collections API. But what Groovy can do, besides having collection literals, you can apply each one of these methods on this collection or any object or a map, and these guys will take care of traversing the collection in the right order, whether this is parallel or whether this is serial, it doesn't matter. You, as a developer, you only need to be concentrated on what is the task at hand, but not iterating over the collection itself. Here are some other examples that make use of the more traditional names in functional programming. So take will grab the head. In this case, take will grab the first two elements, and drop will just skip over the first three elements and give you the tail of the collection. And there are some other variations. We even use head and tail so that you are more comfortable with those names. When Groovy was designed, when the GDK, the Groovy development kit, as we like to call it, was designed, we used these names: final, collect, and inject. Whereas in the usual functional programming nomenclature, we use these other names. So you just have to remember, whenever you see in another example in a functional programming book on another algorithm, they use filter, map, and fold, just switch over to final, collect, and inject. But because Groovy is dynamic, there is a way to regain these verbs if you want to do it. I'll show that in a moment. A year ago, I encountered these two guys at another conference. They were presenting kind of like a smackdown within functional programming frameworks just for Java. This was before JDK 8 was released. And they presented functional Java, Lambda.j, and Google Guava. Now, I asked them for the permission to use their own examples and see what I could do with just Groovy at the time. This is, I think it was Groovy 1.9 at that point. So these were the examples. The excuse was that a group of geeks like ourselves went out of to a pub after a long conference day, and they were enjoying themselves. And at the end of the day, after they drank too much, they had to expense how much they had fun. So they wanted to know more information about the expense list. For example, what was the cheapest beer, what was the most expensive, the name of the one, all the names, and what was the most expensive one. So we can do this, we can solve these questions with Groovy very easily. We can go from a very Java-ish way to a more idiomatic Groovy way. So if you're new to Groovy, perhaps your first approach to iterate over a list of beers will be to use collect. Collect is a reduce operation. So we collect over each element. Remember the it parameter. So we do not define a parameter. We always have access to it. So that's it. We assume this is then a bin of type beer that exposes a price property. So we grab the prices of all beers and then sort them out using the natural sorting, and then grab the first element out of it. This will give us the cheapest one. Or we can use sort in this way and grab the first one instead of using the array index operator. Or we can call the min method. Or if we know that there is already a min method that can be applied to all collections and that it takes a condition out of it, then we'll simply grab the object that has the minimal price. Up to this point, we have a beer object, so we grab the property and prints out the price of that particular beer. Going with the most expensive one could be us turning these conditions around. So again, we start with a list. We reduce the prices, so we get a list of prices. We sort them out, so we got the cheapest at the top and the most expensive at the bottom. So what do? We grab the last. Or we do the sorting again. We reverse the list. Now we have the most expensive at the top. So we grab it here. Or you can use a special comparator. Here we see one of those closures again. This is a nice feature that Groovy had. You can coerce a closure into a functional interface. The same thing that Java does with lambdas. It works with Groovy and closures. Or we can use the max method or apply the condition to the max method itself. And up to this point, we have a beer object. And then we grab the price property. The third one, perhaps this is how we will see it from a Java mindset, is how do we know the name of the most expensive one? First, we have to remember what is the most expensive beer. And once we have it, we ask for the name. So perhaps we do something like this. We iterate. Notice that this is a different iterator method. We iterate over each one, remembering what is the maximum price, so side effect. And once we have it, we apply a find. So we iterate again over the same collection. So that we find this particular object, and then we grab the name. Or we can do it this way. It's up to you whether you are more attached to a Java-ish syntax or a more idiomatic Groovy way. The nice thing about Groovy is that it doesn't force you to go one way in specific. It actually allows you to choose your own way. And finally, grabbing the list of all the names is as easy as, again, reducing over the names. So you get a list of names. Or here we have a special operator that Groovy has. It's called the spread dot. What this guy does, it invokes the getName method over each element of the list, resulting in a list of names. This is the property access. It so happens that because we have a getter on our beer object, we can use the shorthand notation for grabbing the property. So these two are definitely equivalent. And finally, this is what we like to call in Groovy as gpath. So remember about xpath in XML, where you can traverse an object graph of XML nodes. Well, gpath allows you to do the same thing, but with a bean object graph. This works whether your code is Groovy, Java, or any other JVM language that follows the Java beans conventions. So what this guy has done, the shorthand notation, is grabbing the name property out of each element inside that list, generating a new list, and putting the values of those names inside that particular list. Finally, what's the total price? So you can do it this way. This is the long reduce or the short reduce, because there is already a sum method that can be applied to every collection. Okay, so the pros and cons. Well, mostly you are using the same Java collections. There are no mirrors, there are no special cases, no additional classes, same Java collections from Java util. It plays nice with other frameworks, as we will see in a moment with functional Java. And you have access to metaprogramming from Groovy. The disadvantages is that these iterator methods are not lazily evaluated. This is only possible at the moment if you use JDK8 Streams API. And the names, they are not the standard names for functional programming. You can regain those names using Groovy metaprogramming. What we're doing here is that every class in Groovy has a meta class companion. And the Groovy runtime will ask the meta class while the code is being executed if there are any additions that the class may have. What we're doing here is that we're telling the Groovy runtime that if somebody attempts to call the map method on an instance of a list, it actually delegates to the collect method. So after these meta additions, now I can safely call filter, map, and reduce on any list. There's a newer version of streams. So we have some kind of support for streams that are not related to JDK8. Unfortunately, these functions are not lazily evaluated yet, but Groovy will have excellent support for JDK8 streams, which are lazily evaluated. With functional Java, it's very easy to get interaction. One thing, again, we're using the meta class tricks to transform a closure into something that functional Java requires, this particular type. And then this stream class comes from functional Java. So everything that we have here is just a mixture of functional Java and Groovy. It's very easy. Once I posted this slide, somebody from Australia said, hey, I'm building an extension for functional Java and Groovy. And here's the link, and you will be able to see the slides later. Of course, JDK 8. Groovy supports JDK 8. The Streams API, I believe the latest release is not up to speed, but believe me, once Groovy 2.4 gets released, or Groovy 2.5, there will be no problem. It will be exactly the same. Finally, partial evaluation. This is another thing seen by in other languages. It's just simply fixing values in a function and generating a new function that takes less arguments. So we're transforming m from 2 arguments here with curry as a function that takes just 1 argument. And the next question that arises whenever I present curry is that it happens from left to right. Can I do it from right to left? Can I do it in the middle? Yes, you can. 3 different method names. So you can fix any values at any point. And this works with default arguments. I'm running out of time, but I just have to show you that you can also use any object that has this special name. Remember the call in the previous slides? As long as you have this name, it doesn't matter how many arguments, it doesn't matter what it returns. As long as this name, you can create an instance of that object and use it as if it were a function. So now you have a stateful functions. If that makes sense for your algorithm, if that makes sense for your project, this can make it happen. We have composition, applying one function after the other in certain order. Just notice that particular operator. If we switch the operator, it gets applied in the reverse order. Memoization, we don't run, if we apply this method, memoize on every Clojure, then this function, calculating Fibonacci, will not turn out into, well, it will remember every computation that has done before with the same arguments. So Fibonacci 10 is Fibonacci 9 plus Fibonacci 8, which is Fibonacci 9 is Fibonacci 8 plus 7. So you see, Fibonacci 8 has been computed twice. And then as we continue going down the pyramid, then more values will be computed more than once. What memoize does is remembers those values with the same arguments, because functions are supposed to be side effect free. So, okay, total running time goes flat. We can also do trampoline. If we don't use trampoline, which is a way to get around the fact there is no tail recursion in the JVM yet, you can calculate huge numbers like this just by applying trampoline. You don't do this, Stack Overflow immediately. We have, you can create methods as closures with this operator as well. So any method, either it's a static or instance method, can be transformed into a closure. Immutability, just apply a transformation, just one annotation on your classes, and this class now becomes fully immutable. So it follows just blocks rules for in effective Java for creating immutable classes. Just one line of code and you get everything for free. Finally, we have support for concurrency in the name of the Jeepers library, which is included in every download that you have from the standard Groovy distribution. So you get it for free. And parallel collections. And if you ever have to work with monads, there is a monad extension as well. And I think this is all that I have for you guys. I'm definitely a little bit out of my time. Some resources, the slides will be available for you. I hope this quickie has been of interest to you. Just remember, Groovy loves you, and you better love the Groovy because Groovy can be good to you. So thank you very much.